Hello everyone, welcome to our channel Off Campus. In this video we are going to see some problems in basics of network theory. Before going into the video, kindly subscribe our channel Off Campus and click on the bell icon. You will receive notifications. Okay, we'll start the video. First one, 1 coulomb charge is equal to the charge on 4 different options are given. 6.24 into 10 power 18 electrons, 6.24 into 10 power 18 atoms, 6.24 into 10 power 24 electrons. Option D, none of the above. So, 1 coulomb charge, what is that? Know that 1 ampere of current flowing for 1 second transports 1 coulomb of charge. What is actually 1 coulomb of charge is nothing but 1 ampere of current flowing for 1 second. Okay, then a single electron, what is the single electron charge? Charge of an electron equal to, we know that 1.602 into 10 power minus 19 coulomb. A collection of 1 divided by, then we need to 1 divided by 1.602 into 10 power minus 19 electrons, we will get 6.2415 into 10 power 18 electrons have a charge of 1 coulomb. So, 1 by that charge of an electron, we will get the 1 coulomb charge equal to 6.24 into 10 power 18 electrons. Okay. For question number 1, option A is the right option. Then question number 2, the correct relation between energy and charge is. What is energy and charge? Energy W equal to VI into T. What is Q? Q equal to integral minus infinity to I into dt. So, energy equal to nothing but V into I, voltage into charge alone. Okay. Energy E equal to voltage by charge, voltage into charge, or W equal to V into Q. So, energy E equal to voltage into charge. Option D is the right option. Then question number 3, a parallel plate capacitor has plate area A and distance between the plates is D. It has 2 dielectrics, each of thickness D and area 0.5 A. The dielectric constants are epsilon 1 and epsilon 2. The total capacitance is given by the equation. 4 different options are given. So, actually what is given? A parallel plate capacitor has plate area A and distance D. It has 2 dielectric constants. So, since the parallel plate capacitor, so it is both capacitors are in parallel connection. When the capacitors are in parallel, what how the total capacitance or equivalent capacitance will be? Just adding the capacitance value. Okay. So, C equivalent equal to C1 plus C2. So, C1 plus C2 is nothing but C1 equal to epsilon, normally epsilon A by D, right? Epsilon naught, epsilon 1, because it is C1, epsilon 1 into 0.5 A by D. See, this is area is given as 0.5 A. So, 0.5 A by D. Similarly, each of thickness D and 0.5 same area only. So, C2 also epsilon naught, epsilon 2, 0.5 A by D. So, just adding these two values, what we will get? What is common here? Epsilon 0.5 A by D. So, 0.5 epsilon naught A by D, then epsilon 2, epsilon 1 and plus epsilon 2. So, this is the equivalent capacitance. Which one? So, this one common plus adding those values. So, absolute permittivity values. So, that not absolute permittivity, given permittivity value. Option A is the right option. See the rest of the options, this is 0.5 is not here, then some other options are given. So, for this option A is the right option. Then what is that? Fourth one, 2 capacitor, each of capacitance C and breakdown voltage V. Capacitance value, 2 capacitor, each of capacitance C and breakdown voltage V are joined in series. The capacitance and breakdown voltage of the combination is 4 different options are given. We know we need to find out the capacitance value and voltage value. So, what is the charge on a capacitor? Charge on a capacitor is nothing but Q equal to C into V. So, C equal to Q by V. So, C inversely proportional to V. C proportional to 1 by V. C and V are inversely proportional to each other. So, in series combination means what is the equivalent or net capacitance? C1 C2 divided by C1 plus C2 in case of capacitor. Okay. So, what is given? 2 capacitor, each of capacitance C. So, the capacitance value is C. So, C into C divided by C1 plus C2, what will be the equivalent capacitance? Equal to C by 2. So, this is the net capacitance value C by 2. So, we know the relation C is indirectly proportional to 1 by 2. When the capacitance is C by 2, what will be the voltage? 1 divided by C by 2. Right, 1 divided by C by 2 is nothing but 2 voltage. So, it is indirectly proportional, right. So, 1 by 2 will become 2, okay. So, what is the equivalent capacitance? 0.5, C by 2 are nothing but 0.5 C and true voltage, okay. Option A is the right option. So, we need to know the capacitance and the voltage relation, they are inversely proportional to each other, okay. Then fifth one, the distance between plates of a parallel plate capacitor. See, parallel plate capacitor given in the diagram is D distance. The dielectric is in two part, okay. Each of equal thickness but dielectric constant epsilon 1 and epsilon 2 respectively. The total capacitance will be proportional to. So, before also we have derived this na. The parallel is two capacitance C1 and C2 divided by in series, okay. But the dielectric, okay. What is C1? Epsilon naught epsilon 1 A divided by 0.5 D. So, the thickness is 0.5. So, here also epsilon naught epsilon 2 A divided by 0.5 D. So, in parallel series combination means C1 C2 divided by C1 plus C2 proportional to epsilon 1 epsilon 2 divided by epsilon 1 epsilon 2. So, it is proportional to what is given in the question, the total capacitance proportional to this one epsilon 2 divided by epsilon 1 epsilon 2. So, this one option A is the right option. Then question number 6, two capacitors of 1 microfarad and 2 microfarad capacitance are connected in parallel across a 30 volt DC battery. 1 microfarad and 2 microfarad in parallel connected across the 30 voltage DC battery. After the capacitance have been charged, the charges across the two capacitors will be. We need to find out the charges of the capacitor for for this one and this two, okay. What is the formula? Q equal to CV, okay. So, we need to find out the Q1 equal to C1, 1 into 10 power minus. So, in parallel combination voltage is the same voltage will be in this capacitor and also in this capacitor, okay. So, into into 30. So, 30 microcoulomb. Here Q2 equal to 2 into 10 power minus 6. 2 into 10 power minus 6 into 30. So, 2 into 30 60 microcoulomb. So, Q1 30, Q2 60 30 and 60 microcoulomb respectively. Option C is the right option. Then for this capacitor we know we should know the relation between the formula Q equal to CV. So, most of the problems based on this relation only, okay. Then question number 7, two capacitors are connected in series, 1 microfarad and 2 microfarad are connected in series across a 30 volt DC battery. See, it is connected in series across a 30 volt. After the capacitors have been charged, the charge across the two capacitors. So, we need to find out the two capacitor charge. So, here since the capacitor is in series, how the total capacitance will be C1 C2 divided by C1 plus C2. So, 1 into 2 divided by 2 plus 1 we will get 2 by 3. This is the total capacitance value. So, Q equal to CV. So, 2 by 3 into 2 by 3 is the C value. What is the voltage? Voltage equal to 30. So, 2 by 3 into 30 equal to 20 microcoulomb each. So, the capacitor is in series. So, the charge is same for both of the capacitors. So, 20 microcoulomb each. Option B 20 microcoulomb each is the 20 microcoulomb is the right option for this problem. Then two capacitors of 2 microfarad and 4 microfarad capacitors are connected in series across a 30 volt battery. After capacitors have been charged, the voltage across them. We need to find out the, because in series the voltage is divided, right? In parallel only the voltage is equal to, same voltage is applied, dropped in each of the value, each of the capacitors. For in series combination the voltage is divided. So, we need to find out for the 2 microfarad voltage drop for this capacitance and voltage drop for this capacitor. Okay. So, charge will be the same only. So, because it is in series, the charge will be same, but the voltage is divided. So, what we need to do, first we know the one formula, we know two capacitance value. So, 2 microfarad and 4 microfarad and one voltage value. So, we need to find out the voltage drop for each of the capacitors. So, since the capacitors are in series, the charge will be same for the both for the capacitance. Okay. So, we need to find out the charge. Well, C equal to, this is in the net capacitance. First we need to find out the total capacitance, C1 C2 divided by C1 plus C2, 2 into 4 divided by 2 plus 4. So, 8 divided by 6 we will get 4 by 3 microfarad. So, this is the equivalent capacitance value. Then we need to find out the charge. As I said earlier, charge will be same whenever the capacitor are in series. So, charge, what is the charge? Q equal to C into V. Total capacitance 4 by 3. What is the voltage? 30. So, charge will be 40 microcoulomb. So, we know the value for charge and we have to find out the voltage drop across each capacitor. So, VC1 equal to, this is a general formula, or we can write VC1 from this formula. V equal to, for voltage drop across the capacitor 1. So, VC1 equal to Q by C1. Q by C1 for 40 divided by 2. So, 20 volt. Again VC2 equal to Q by C2. Q is same, 40 divided by C2 equal to 4 equal to 10 volt. So, 20 volt and 10 volt. 20 volt and 10 volt. Option C is the right option for this problem. Don't confuse guys, because in option also they are giving for us to confuse 10 volt and 20 volt. So, please keep mind in that. Be careful while clicking, while finalizing the options. Option C is the correct option for this problem. Then question number 9, in a practical voltage source, the terminal voltage will be how? In case of practical voltage source, cannot be less than source voltage, cannot be higher than source voltage, is always less than source voltage, is always equal to source voltage. Option B is the right option. Which one? Cannot be higher than source voltage. In practical voltage source, the terminal voltage cannot be higher than source voltage. Then question number 10. An ideal current source has infinite source resistance, large value of source resistance, zero source resistance, finite value of source resistance. So, for ideal current source has infinite source resistance. Option A, infinite source resistance, is the right option for this question. Then question number 11, Kirchhoff's laws are applicable to DC only, as sinusoidal wave only, DC and AC sinusoidal waves, all wave shapes. So, Kirchhoff's law are applicable to all wave shapes. So, answer D, all wave shapes, is the right option. Okay. Then 12. When determining Thevenin's resistance of a circuit, 4 different options are given. All sources must be open circuited, all sources must be short circuited, all voltage sources must be open circuited, and current sources short circuited. Then option D, all sources must be replaced by their internal resistances. So, when determining Thevenin's resistance of a circuit, all sources must be replaced by their internal resistances. Option D is the right option. Then move on to next problem. A source is delivering maximum power to a resistance through a network. Okay, it delivers maximum power. See, then ratio of power delivered to the source power is always 0.5 or 0.4. Different options are given. Let's see how to solve this problem. So this is AC circuit, RS and RL. This is a network. Network may be anything. So when the maximum power will be delivered to the load, when it is whenever source resistance equal to the load resistance, the maximum power is delivered to the load. This is called as maximum power transfer theorem. So RS equal to RL equal to R. So if the network is lossless, then what is the current? Lossless means I equal to V by 2R, which means that I equal to V by RS plus RL. Okay, I equal to V by RS plus RL. So RS divided by RS plus RL equal to RL on V divided by 2R. So power delivered equal to I squared into R. I squared into R equal to V squared by 4, this square, V squared by 4 R squared into R. So by cancelling this, what we will get? V squared by 4R. By substituting power delivered, how can power delivered equal to I squared by R? I equal to V by 2R. By substituting, we will get power delivered equal to V squared by 4R. So then we need to find out the source power, because we find out the power delivered to the load. Power delivered equal to I squared R. Source power equal to, we need to find out the ratio of power delivered to the source power. So then source power equal to VI. So what is I again? I equal to V by 2R na. So V into V by 2R equal to V squared by 2R. Then what is the ratio? Ratio of power delivered to load divided by to the source power equal to V squared, this one, V squared by 4R divided by V squared by 2R. We will get this V squared and V squared by R, V squared by R will get cancelled. 2 by 4 we will get 1 by 2. Then 0.5. So option B may be 0.5 or it should be less. Okay. Answer B may be 0.5 or less is the right option. Then question number 14. 3 resistance of 15 ohm each are connected in delta. The resistance of equivalent star will have a value of, so if 3 resistance equal resistance means we have one simple formula, N by 3. Whenever delta to star, whenever equal resistance, by converting delta to star, it is nothing but N by, N is N by 3 or R by 3. So R value divided by 3. So again vice versa, see whenever star to delta, whenever equal resistance are given, we can convert easily into 3 into R. So whenever converting delta to star equal resistance, in case of equal resistance, just divide by 3. So 15, it is applicable only for the resistance or in equal. Resistance value should be equal. So 15 divided by 3, what we will get? 5 ohm. So answer B, 5 ohm is the right option for this problem. Then next one, 2 voltage V1 equal to 100 sin omega t plus 15 degree and V2 equal to 60 cos omega t. Then 4 different options are given. So leading or lagging, V1 is leading or V2 is lagging, V leading, we need to find. Then leading by how much degrees, okay, we need to find. So V1 is given is 100 into sin omega t plus 15 degree. So V2 equal to 60 cos omega t. 60 cos omega t, how can we write? Sin omega t plus 90 degree is equal to cos omega t, right? So sin omega t plus 90 degree. See the degrees. So 90 minus 15 equal to 75. So which one is lead? V2. V2 only leading. Okay, V2 is leading V1 by how many degrees? 75 degrees. So V2 is leading V1 by 75 degrees. Option C is the right option. Then which one? Question number 16. In a purely inductive circuit, the current, in an inductive circuit, current See, current lags by 90 degree. Okay, in an inductive circuit the current lags the voltage by 90 degree. So C lags 90 degree is the right option. Then in a purely capacitive circuit, current leads the voltage by 90 degree. So leads 90 degree, option B is the right option. Whenever inductive circuit, current lags the voltage by 90 degree. Capacitive circuit, purely capacitive circuit, current leads the voltage by 90 degree. So then move on to the next one. The current wave shape shown in figure A is applied to a circuit element. The voltage across the element is shown in figure B. The element is, so this is the current wave shape is applied to the circuit element. This is the voltage across the element. So whenever current pulse is applied to a capacitor, the voltage is rises linearly and becomes constant at the end of the pulse, which means that it is it is a capacitor. Vc equal to 1 by C integral I dt. So option C, capacitor, is the right option. C. Then question number 19. In the following figure, the charge on 0.8 microfarad capacitor is. So we need to find out the charge for this capacitor value, 0.8 microfarad capacitor. So 100 voltage DC is connected across this circuit. So these two are in parallel. Whenever capacitance is in parallel combination, just we need to add. So 0.2 plus 0.8 we will get 1 microfarad, right? Again these two in parallel combination. So 0.7 plus 0.3 1 microfarad. So 1 microfarad in series 100 voltage. So voltage is divided in series connection, right? So for equal capacitance value only, so it is equally divided. For this capacitor it is 50 voltage, for this it is 50 voltage. So for this series it is 50 voltage is dropped. So what is in that question, what we need to find out? For charge on this capacitance. So this capacitance, so 0.8 into what is the voltage for this voltage drop for this combination, what is the voltage of 50 voltage. So 0.8 into 50, so because Q equal to C into V. C value 0.8 microfarad into what is the voltage value 50. So 0.8 into 50 equal to 40 microcoulomb. So what is the option? Option C. Option C is the right option. 40 microcoulomb is the right option for this problem. Then this is the final one. A bulb rated 60 watt 120 volt is used for 30 minutes. The charge associated with this operation. What is the charge in generally? So we need to know that W equal to VA. Already we have seen energy equal to voltage. W equal to V in voltage into current equal to power. Okay. Then what is I? I equal to W by V. Otherwise I can be I equal to dq by dt. So q equal to I into t. So we know the what is given, what is I. So q equal to I into t. We need to find out the charge associated with this operation. So what is the formula? I into t, because time is given. Time should be in seconds, okay, but given in minutes. We'll see. Q equal to I into t is the formula. Then Q equal to what is I? I equal to W by V. So W by V, 60 by V into T. T should be in seconds but given in minutes. So 30 into 60. How to convert 30 into 60? Minutes is converted into seconds. By simplifying, what we will get? 900 coulomb. Charge will be 900 coulomb. So 20, option B, 900 coulomb is the right option for this question. Then okay, we'll end up the session up to this. Thanks for watching. Like, share and subscribe.